Hi, my name is Daniele. I'm from the State University of Ceará, and today I'll be presenting the article called Identification of High Delay Links in Internet Service Providers. This presentation will be separated in 6 topics: Introduction, Related Works, Proposed Tool, Experiments, Results, and Conclusion and Future Work. In this section, we discuss the challenges faced by Internet service providers in monitoring network performance, particularly in detecting high delays in communication links. It is crucial for entities such as Internet service providers, companies, and institutions to utilize network monitoring service to evaluate performance metrics and data. So, when it comes to quality of service, we need to be aware of end-to-end latency impacts, efficiency, and effectiveness. Here, we show the harm that high delays in end-to-end communication can cause. They can be such as slow transmission bit rate, congestion, and even system failures. On the other hand, low and efficient delays can promote many benefits, such as improve customers' network experience, resulting in increased productivity and overall system performance. Now that we are aware of the need of identifying high delay communication links, we can show in more details how can this benefit Internet service providers. The first benefit is the capacity planning. It allows organizations to anticipate future demands and allocate resources accordingly, avoiding network congestion. The second one is quality monitoring, enabling Internet service providers to measure and track network performance over time. Then we have resource allocation, enabling organizations to allocate more resources to critical links and reduce unnecessary expenditures and underutilized ones. Finally, we have performance optimization. Avoiding high delay links can consequently reduce end-to-end latency. In this section, we present how the RNP network infrastructure works. Here is a map of how the connection of the RNP network is established in Brazil. The links in dark blue have a higher connection speed, and the ones in pink have a lower connection speed. This network provides high-quality internet access and transfer of substantial volumes of data for scientific projects, and the advancement of emerging technologies covers the entire national territory. Our proposed method requires 2 pieces of information to perform identifications: end-to-end delay and end-to-end communication trace route. We went through 4 stages of development before reaching the final result of this article. They were data collection, where we used the monitoring service data of RNP, the identification of high delays. We searched for high delays that are greater than 6 milliseconds, and from this trace route data, we selected the links that are part of the path of these high delay cases. Then, we calculated the correlation matrix, and finally, we calculated the impact score. The data correlation technique we used is the Pearson correlation coefficient. It's a number between -1 and 1, with -1 indicating a perfect negative correlation, 1 indicating a perfect positive correlation, and 0 indicating no linear correlation. That measures the strength and direction of the relationship between 2 variables. This correlation is calculated by the equation below. After the calculation of the data correlation matrix, it is necessary to extract knowledge about the current network infrastructure situation. So, we designed this impact score. It represents the degree of responsibility of a communication link in cases of high delay in the network infrastructure. It is calculated by the equation below. In this section, we present the results of the experiments using real data from the RNP. In the experiments we performed, we collected the data at 3 distinct times. These times were chosen due to schedules with more measures of high delay. Here we have the correlation matrix of 3 distinct times of the same day. This heat map shows in dark red the links that showed correlation value close to 1. With this correlation matrix, we can obtain valuable information about the potential cause of the issue of high delay, but we cannot use it as a sole source of analysis because it may not provide a relevant picture of the performance across the links. But the higher the score, the more likely the link is contributing to the high route delay. Then, with the impact score, we used the same 3 times in the same day, and we found that within the 3 minutes interval, the same 3 links showed a high score. The addition of the impact scored information makes possible to provide a better indication of which one of the links may be responsible for the highest delays. We can conclude where the problem may be present, indicating a solution more targeted for these cases. Finally, in the conclusion of these articles, we found that even with the many companies and internet service providers offering network monitoring service, it remains a need for the ongoing evolution of monitoring tools to address more intricate tasks such as the detection of high delays. Our proposed method brings better identification of possible causes of low network performance, helping network managers optimize network performance, reduce costs, and improve user satisfaction. For our future work, we'll be analyzing a larger time window and consider cases of good performance. We will also add analytics based on other impact score, considering in this the cases of good and bad performance to an end-to-end communication. This addition of more metrics will be a good addition for our analysis because it will make it more accurate. Thank you for all the attention.